today's discussion point is around how is the energy efficiency market in the Arab region, like especially for buildings. What are the major challenges? What are the major enablers, and how we can go about it? Hope the screen is visible now.
Yes.
Great. All right. Thanks. So basically, we'll first talk about what is the rapid urbanization that is happening in the world and then in the Middle East as well. So these are some numbers which we are all familiar with. Buildings, the overall global energy consumption breakup in that buildings constitute about 40% of the overall consumption. Industries another 32 or so. And if we are looking at buildings specifically, where it's about this is the utility consumption breakup in buildings typically. HVAC is the major energy guzzler in buildings, right? It's about 60 to 70% of the overall consumption just by one utility, and that is HVAC. So this becomes a major focus point for most companies today to begin with in terms of implementing energy efficiency measures. And if you're looking at the Middle East, especially, in buildings and commercial industries, the segments are about 59 to 60% of the overall energy consumption. So, and these are also heavily air-conditioned spaces, especially buildings again. So that's a major focus area when it comes to starting with energy efficiency measures. And while HVAC is the major guzzler in there, another key challenge or a key problem today is that we are facing is climate change, global warming. So you can see that over the past few decades, global mean temperature difference has only been consistently increasing, which correlates to the requirement or the demand for air conditioning again for addressing or catering to the needs of the end users. So that's where once again
Sorry, Ms. Aparna. Please, we would like to ask the participants to stay on mute while the presentations are ongoing. You can go ahead and continue. Sorry.
No problem. Thank you. All right. So the point again is that with the global climate change that is happening, the increase in HVAC demand is only going to go up. So that's another focus area that we need to keep looking at. So looking at what are the major challenges and major enablers that are there in the Middle East market again. So some of the major challenges is one, the fuel or the electricity prices are again highly subsidized. So when an end user or a customer decides to adopt an energy efficiency measure, while there is a reduction that happens in their overall energy consumed, kilowatt hours consumed, correlating that to a monetary value might not really make much sense, or the return on investment ROI might not be very significant because of the subsidized fuel prices. So that becomes one challenge in this market. Secondly, the increase in awareness again needs to be implied upon. So while there are a lot of forums and initiatives like this to increase environmental awareness, this again we've seen that has been a lot more focused for buildings, for larger real estate infrastructures, for industrial segments. But again, what about the other smaller segments, right? The small to medium sized buildings, where there is a limited awareness in terms of environmental awareness. So that becomes another focus area. And the clean energy deployment, again, I think there's a lot of focus in the commercial and real estate segments, the industrial segments, and how can this the smaller markets, so the small building market, adopt a clean energy technology? That becomes a challenge. And obviously, it's urbanization that is happening. Your populations are growing up. Their demand for living standards have also increased. So these are some of the major challenges that we've seen when it comes to adopting energy efficiency measures. And at the same time, there are a lot of opportunities as well, right? So the Middle East government has taken a lot of initiatives, a lot of regulations have put in place, especially for buildings, where there are a lot of standardization being done to ensure that there's one maximum level of participation happening, and the performance of the buildings is also improving. So that is, of course, one of the major opportunities that is there in here. Secondly, energy efficiency retrofit programs. You can see a lot of organizations today going for retrofit programs. A lot of ESCO initiatives are taken up. So this clearly indicates that everyone is working towards net zero goal of the Middle East region, and everyone is adapting to that. Thirdly, clean energy policies. Quite a lot of clean energy policies have again been rolled out by the Arab governments. And at the same time, there's a need for technology adoption as well. So while there are a lot of conventional technologies like BMSs and all being extensively deployed over here, the interesting part is now there's a lot more curiosity built around newer technologies like IoT, and how data analytics can help in terms of improving energy efficiency in buildings. So we will get a little bit more into the building automation space now, or the smart energy management space. So buildings, again, I wouldn't categorize buildings as large, commercial buildings alone, but again, the smaller infrastructures, which are a lot more challenging to maintain and manage, right? So because number one, these are smaller in area, which means it's not easy to deploy a BMS equivalent solution for building automation in the smaller infrastructures. It might not make economical sense. Secondly, these are geographically quite distributed, which makes it all the more challenging to manage multiple buildings in a standardized manner. So while there may be corporate governances rolled out about maintaining certain budget energy consumption patterns across all your smaller buildings, it's difficult to track it. It's difficult to keep a daily governance of it, and over a period of time, probably it might not be effectively used. Whatever energy efficiency measures are put in smaller buildings might not be effectively used as well. And obviously, there are a lot of significant segments in here, like the retail chains, multiplexes, co-working spaces, which fall in this category. The second category, of course, we are all very familiar with, where again there's a lot of measures taken in terms of improving efficiency, but there are again challenges being faced over here. Firstly, you would have a typical BMS deployed, but again there are challenges around maintaining the system, right? It could be a high cost. Over a period of time, it needs some upgrades. Maybe the sensors and the cables are not effectively working. There's a lot of retrofit work to be done to maintain the BMS system. So over a period of time, it might not be as effective as it was envisioned to be. And then it needs to have a OEM agnostic approach. So while a building owner might have three to four different buildings, it might have different OEMs in different buildings, and making them talk to each other on a single platform becomes different. So the OEM agnostic approach for larger buildings is another challenge. And obviously, we are all moving towards a wireless technology now. While in with traditional systems, it still depends on a significant amount of cabling and a significant amount of hardware being put in buildings. So these are some of the typical challenges when it comes to building automation. And other energy leakages that typically happen in buildings, right? You have equipment not operating when it is not required. There is no one present in the building, especially in office spaces. This is typical scenario here. Inefficient settings, HVACs being set at suboptimal temperatures, while the demand is not really as per that. So that's another energy wastage happening there. Your equipment may fail, there's a poor maintenance, and other electrical related concerns also, electrical parameter related concerns also, which might not be getting noticed on a day-to-day level. So some of the other energy leakages typically happening in building are around that. And further delving into what are the other challenges around maintaining or managing a building automation or building management system is mainly around these points. So like I told, it's mainly suited for larger buildings. It's a lot of significant cabling happening in there. CapEx could be high. Mostly these are on-premise solutions, which means while there is a BMS deployed in a building, all the buildings are operating in silos, and it is dependent on the BMS engineers and the effectiveness with which they are utilizing the system when it comes to achieving the end goal of getting reducing your CO2 emissions to begin with. And over a period of time, like I mentioned, it is difficult to maintain with the extensive amount of hardware that gets put in. And beyond that, while the BMS system is typically meant for a smart control building automation platform, it's more of a reactive system. There's no data analytics, there's no predictive maintenance happening, and which makes it more like a platform for controlling all the utilities from a single desk or a single screen. But beyond that, we are capturing a lot of critical data. How can we use that critical data to make your building work for itself and continuously keep adapting to the various needs of the building? So that these are some of the major challenges again when it comes to BMS in large buildings. So now coming into what can a technology like IoT do in this space, and how can it help improve the energy efficiency? Firstly, what is IoT? How does it work for larger or smaller buildings as well in terms of decarbonization? So it's basically IoT, Internet of Things, is a technology in which you're connecting devices and making them talk to each other, right? And with the data that is being captured, there's a lot of analytics which runs on an AI ML platform to to further improve the operation of the systems. So obviously there is some amount of hardware that needs to be put in, like your sensors, your actuators, certain gateways to connect the field devices, and then from there connecting it on typically a cloud-based platform, which gives the other benefits. So firstly, if you're connecting on a cloud-based platform, it gives a centralized visibility. You can have multiple buildings, within a building, multiple assets connected, and then multiple buildings connected over a cloud platform, which gives a centralized visibility into which building is performing better than the other, how are your EPIs, etc. And controls as well. So it's not just the feedback that goes in and it's working based on a reactive platform, but utilizing the data, like how has been the energy consumption pattern of your building, what is the temperature profile of the various sections of your building, and adjusting the controls continuously to make it a more intelligent and smart manner or methodology of making use of all the energy efficiency measures put in there. And obviously, a byproduct of taking these two measures is the predictive maintenance. So you're capturing critical data of your equipment, like your ACs, right? So with that, we can also use this data to predict the health, to study the health of the equipment and predict in terms of a breakdown that could likely to happen in maybe a month or 2 months time or so. So it's a more holistic approach over here, while the focus is on energy efficiency. Obviously, with the automation platform, there's about 10 to 20% energy efficiency improvement savings that happens. Compliance factors will also improve by keeping a track of your temperature, humidity, indoor air quality, etc. And raising an alert in case any of these compliance factors are not within the required range. And obviously, like I said about predictive maintenance, so if it is done in a predictive manner, there's a significant amount of breakdown reduction that happens. And IoT being mostly wireless technology, a modular technology, I don't need to have all the gateways connected to a single hardware in the building or the servers in the building, which means there's a significant amount of hardware reduction in terms of deployments, which again impacts the capex of the project. So the hardware works to about 18 to 20 months in this scenario. Dwelling a little bit more into what the typical architecture, right? So, like I said, HVAC is the major focus area for most IoT companies, us included, since that's a major energy guzzler, and it is also the load that continuously keeps varying inside your building depending upon the need as well. So, the typical assets that we connect with are we begin with HVAC, lighting. Refrigeration is another utility which again consumes quite a lot of energy and is important for monitoring your code compliances. So, when we are talking about different cloud kitchens or QSRs, restaurants, even hospitality segment, refrigeration load is quite significant, and tracking this is critical as well. And other critical assets like your UPSs, your fire alarm systems can also get connected on IoT. What you see in the middle are the typical hardware that we would need to put in to connect these devices. So again, like I said, it's quite minimal. There are the field devices, the sensors, the controllers, and then there's a gateway connecting to these devices. The gateways just need to connect on cloud, right? And then on the cloud platform, all of them get mapped, and then we're able to get the visibility into the overall building's energy efficiency and whatnot. So just by having this connected platform, we are able, customers can see energy efficiency, at least up to 10 to 15% cost reduction, energy cost reduction. You're obviously maintaining a compliance of your temperatures, your humidities, etc. And the major differentiator is that you're digitalizing all the critical assets in your building and bringing it on a connected platform, which gives, and once you monitor, you can also control systems. What you can't monitor, you can't really have a grip upon, right? So that's why digitalization of all these assets and bringing it on a connected platform becomes critical for buildings and such infrastructures. And these are the typical use cases. It begins with power monitoring, and then connecting the various HVAC loads, monitoring the other parameters, especially ambient parameters, and integrating with existing systems. So in a manner, just trying to see how we can, with minimum intrusion in a building, how we can have an automation platform built around it and improve the energy efficiency. And I think what's very critical for buildings, especially, is to have it. I've been telling this, but connecting the buildings on a single platform is very critical. So you would have various types of buildings here, right? You may go into a hotel and you see that there's a full-fledged BMS deployed over there. The same organization may have a warehouse where it's a partial BMS only for HVAC, not the other utilities. Or maybe the same organization has an office space where there's no BMS deployed as such, and there's no automation also available there, and some new projects are also coming in. So it's important to have an approach in which we can have an OEM agnostic manner of connecting all these buildings. So wherever there is a BMS with IoT, we can integrate with existing BMSs over open protocols. Where it's a partial BMS, we connect it with the existing BMS, add in additional hardware to fill in the gaps, or deploy a full-fledged IoT BMS for a building where there is no such automation done. And connecting these on the single platform gives visibility to the corporate build owners or corporate project leaders of all your typical parameters. So you can compare similar buildings. You can see that the budgeted energy consumption for all your buildings are not crossing, and being able to predict that, with the AI platform, being able to predict whether the building is going to cross the threshold energy consumption or the budgeted energy consumption for this month or not becomes possible with the connected platform. And obviously, the whatever energy efficiency measure is taken in a building, it ultimately it depends on how the site engineers are utilizing it. So even they get connected into the platform. So it's a top down approach in which from all levels everyone is connected onto the platform, and they're able to see the day to day activities and the day to day parameters as well. So this is again something that becomes critical. While a lot of energy efficiency measures are being taken, it is important to track it and see to it that whatever measure was taken, it is effective, and it is really yielding the result that was for which this was signed off for. So yeah,
Miss,
that's some of the major benefits of the technology, the IoT technology. So, like I said, net zero goals. Every organization today is adapting net zero goals. Right, and net zero buildings is the main goal for most organizations today. While this is again being implemented, keeping a track of the parameters is critical, and that's where we can probably come in and help. So that's mostly it from my end in terms of the points to be covered here. Some typical use cases which also relate to this, capturing scenarios where the building is not operating in an efficient manner, capturing scenarios where equipment is not being are being operated when it is not really required, and about asset health as well, right? So if your simple things like your chillers are not performing, your IKW per TR is not being maintained, or your chill water valve is not operating as per the required limit. These are some of the analytics which can be brought out with a smart energy management system, and with the predictive maintenance, we can start reducing the asset breakdowns as well. So yeah, I think that's mostly it from my end. This is just a background about the company. We started in 2014, and have about 2,800 deployments across the country and now in the Middle East as well. So yeah, that's mostly it from my end.
thank you so much, Ms. Aparna, for this very informative and interesting presentation. And thank you for your time.
Thanks a lot. Thank you.